chapter 11.1 on properties of gases. Gases are like any material. Any material can be a gas. You could boil gold if you wanted to and turn it into gas. So the properties of gases are interesting, and there's a little bit of concept here. You have to realize that a gas will fill its container. So a liquid would stay to the bottom of a jar, for instance, but a gas would fill the jar if it had a lid. And if it didn't have a lid, it would go out of the jar and fill the room that jar was in. And if the door was open, it would keep filling the house. So a gas is always going to expand and fill its container. That means that the molecules that is in that gas is very far away from each other. So we're going to look at just some ideas, and the theory is called the molecular theory of gases. If they're in the gas phase, that means they've got more energy than they did in the liquid phase. And a liquid has more energy than it had in the solid phase. So a solid is not just at the bottom of the jar, but it's in a specific shape. Like it maintains its shape. Liquid at least can go over top of each other. But if you energize that liquid, it will have enough energy to escape out of that material and into the surrounding above the liquid. So you're going to have a gas layer above a liquid. And it will continue to fill until it fills its container. So the ideas here are called the kinetic molecular theory. So kinetic has to do with movement. So kinetic energy, if you remember, was energy due to movement. How fast that the car was moving was its kinetic energy. The molecules of gas moving at very, very high speeds. So that's the first idea, that you're going to have them bopping very, very fast around, banging off the wall, banging off the floor, banging off the wall, banging off the ceiling as it bops around. If you make the room bigger but keep the same amount of gas, it takes longer to get to the wall. It takes longer to get to the ceiling. It takes longer to get to the floor, but it's still moving around. All right, so in the next class, we'll talk about the pressures, and the pressures have to do with the force of this banging gas along the side of the container. So we'll talk about a balloon expanding when it gets warmer because it's energizing the molecules, banging against the sides more, and it will inflate the balloon. A cooler balloon would deflate for that reason. Okay. The other part of this theory is that they're not actually attracting to each other. Not even gravity is conceived here. The idea that these two molecules have mass, and even though they're in a gas stage, they're massive, and that this gas kind of coalesces. In order to get something like a star to form, where you have gases coalescing and condensing together, really breaks this theory. So the theory really can be thought of up to a certain limit. But the idea of how a gas works is that it's bopping around at high speed and that it's really not attracting to each other. Think of them as no attraction, even though that there is gravity. So you have to kind of fudge this. They're very far apart. If it's filling the space, then most of the space is empty space. So think of them as particles inside a container with almost everything else is not a material. It's just empty vacuum. Okay, and if you also think of it conceptually as not having its own volume. So that molecule does have a shape. It does have a size, and it by itself is filling that space. But really, you're thinking of it as having a very small volume compared to the volume of the jar that it's in or the balloon that it's in. And then as the temperature goes up, you're going to they're going to speed up the molecules. That's the kinetic part. The molecules is the molecular part. The kinetics is how fast it's going. As they speed up, they're going to bop on the sides and the floor and the ceiling more frequently. And because of that, you're going to end up with a bigger balloon because the pressure will go up. So we'll talk about that when we get to pressure. See, told you it was easy.